Okay, hello and welcome to lesson 9 of Inequalities. And it's imperative that you've worked through the previous lesson, lesson 8, before you do this lesson, because this is a kind of extension of where you were in that last lesson. And we were working on this one, the solving quadratic inequalities, and we're still working on that today. We've just got a little bit of work to do before we get to the actual factorising and solving part. So your title is very similar, solving a quadratic inequality. I've called it part 2 just because it is an extension from where we were. So essentially you're presented with something like this, and your thought process needs to be, when you see this or when you see a question like this, we're looking to try and get all the terms onto one side first, the same as you would do with a normal quadratic. We're looking to get all the terms onto one side first so that it equals 0, or in this case it's greater than 0 or less than or equal to 0, before we try and factorise and solve. Okay, so the key with all this is, can I make it equal to 0 before I start? So with this, I'm looking to just subtract 100 from both sides. So when I subtract 100 from both sides there, I get x squared taken by 100 is less than or equal to 0. So at this point, I can now factorise and solve that. The only the only difference with this one, I guess, is the fact that when I look at that left-hand side, I should be thinking a specific type of factorising, because that's a specific type of quadratic. So I should be thinking difference of two squares. If you can't remember that, or if you haven't done that before in theory, just make sure you look that up on Hegarty Maths, factorising using difference of two squares. But we're looking to square root the x squared, square root the 100, and then you have 1 plus 1 minus in your brackets there. That's difference of two squares. Now, critical values from there. Are 10 and negative 10. A sketch of that. Gives us something looking like that. And then we just do what we normally do, what we did in the previous lesson, which is to try and identify, am I below the x-axis, am I above the x-axis, and therefore can I write my inequality as one combined inequality, or as two separate inequalities. So when I look here, I'm looking for when this quadratic is less than or equal to 0. So less than is when I'm below the x-axis, and when I've got one continuous section here, and that section of x's is greater than negative 10 or less than 10. I've got my equal sign here, so I just need to make sure I have my equal sign here as well. So that's my answer. If you could copy that down and just emphasise you're looking to move everything onto one side first before you try to factorise and solve, okay? So straight into this second example, which again, very similar in as much as we're looking to get everything onto one side before we factorise and solve. So I'm looking to subtract the 8x, subtract the 9, so that I've now got a quadratic inequality that looks like that. From there, it's just exactly the same as what we were doing in the previous lesson. So factorise, solve, critical values, sketch, that sort of thing. So I'm using 9 and 1. So negative 9 and positive 1 to get the values I need from there. So my critical values 9 and negative 1. With this one, I'm looking for when this is greater than 0. So I'm looking here, and I'm looking here. When it's above, you've got two separate sections there, so two separate inequalities. I'm looking for when x is less than negative 1, or when x is greater than 9. Okay, two separate inequalities for that answer there. Okay, example 3. Similar, but we've just got a bit more work to do this time to get everything onto one side initially. Okay, that's always our aim with these questions. Get everything onto one side initially, and then I can factorise and solve. So I need to make a decision about which side I'm going to move things onto. The way I would make that decision is by looking at the x squared terms first of all, because I want to keep the x squared positive. Okay, I don't really want to try and factorise something that's got a negative x squared, and it adds difficulty that I don't need to be there. So I'm looking at the x squared. This is 4x squared, that's 3x squared. So I know if I take this one away, then that will leave you with a positive x squared. So I'm going to do that. I'm going to move everything onto the right-hand side here. So I take away 3x squared. Which gives me that. So 4x squared take away 3x squared gives me just 1x squared there. I add the 5x. And I add the 1. Now from there we can work on what we normally do in terms of factorising and solving, sketching. If you're less comfortable with having it that way round, you can swap the inequality around there and just have the quadratic on the other side as long as you swap the inequality sign. So what I mean by that is that this is exactly the same as this. Okay, this says x squared plus 12x plus 20 is greater than 0. This says x squared plus 12x plus 20 is greater than 0. They're saying the same thing. But if you feel more comfortable having it this way around, fine, that's okay. We'll look to factorise this. We're looking at 10 and 2. And then critical values there. So, quick sketch. And finally, I just need to make sure I understand which bits I'm looking for. So I want this quadratic to be greater than 0. I would always try and do it from when I've got it to 0. I wouldn't try and work out which side I'm looking here in the initial question. I'm looking for when I've made it effectively equal to 0 or greater than 0 at this stage. So I'm looking for when this is greater than 0. So I'm looking here and here. So x is less than negative 10, or x is greater than 2. So above the line, so we're looking at two separate inequalities. Okay, finally, this is kind of the most complicated version of the question we tend to get. So this is off a GCSE paper. This was question 20 out of 21. So we're talking right at the top of grade 9 for this question. Now, the reason this is, in theory, so difficult is because you've got a quadratic inequality here that needs to be rearranged. You've also got a linear inequality here, and what the question is saying is that I need to find the values of n which work for this one and for this one. So I need to find values that will work for both of them at the same time. Now, we'll concentrate on the quadratic part initially, and then we'll come back to the linear part. As I say, this would be right at the top of grade 9 in terms of difficulty level. So if I look at this initially, what I'm seeing there is I've got a fraction. I kind of understand that I want to get it all onto one side, but to do that, first of all, I've got to deal with the fraction part. Now, when I see a fraction like that and I'm thinking about rearranging, I know that I need to move the denominator first. So I'm going to multiply by that denominator, multiply both sides by the denominator. So I'm going to times both sides by n squared plus 5, which gives me 6n on this side. And effectively it gives me 1 lot of n squared plus 5. Okay, so I'm timesing the denominator by that number there. Now, in reality, you don't need to write the 1 there because 1 multiplied by this is just going to give you that. So if you wanted to just write that, you can. But I want you to understand that you're multiplying by that number. It just so happens that number is 1. Okay, from here, I'm looking to get everything onto one side. So I'm going to take away the 6n. And I have this quadratic here. So at this stage, I'm looking to do what I normally do, factorise, solve, critical values, that sort of thing. So I want both of them to be negative, to make the negative 6n in the middle. Critical values there. Quick sketch. And I'm looking for when this quadratic is less than 0. So I'm looking for when this is less than 0. So the middle bit there is when it's below the x-axis. So I'm looking for n to be greater than 1, but less than 5. So that's done the bulk of the work there at this stage. Okay, I've done kind of the most difficult part of the question at this point. I'm now going to return to the linear part of this, which was 3n plus 2 is less than or equal to 14. I need to think back to some of the early lessons we did on inequalities and think if it just looks like that, I just solve it as if it was a normal linear equation. So I move the 2 and then divide by 3. So we're going to take away 2 from both sides. So subtract 2 from both sides initially, then divide by 3. And I've got that. So that's my solution for the linear inequality. Now, I've got to just read this question again and just make sure I fully answer the question. N is an integer. So that's one of those words that we talked about early on in this topic as well. Integer means whole number. So n is a whole number such that this is true and this is true. So I need to find the possible values of n for which both of these things is true. So you can list these off if you like, and you can say n is less than or equal to 4. So what I'm looking for there in terms of whole numbers is I've got 4, 3, 2, 1, 0, -1, -2, and so on. Okay, that's infinite there because it just needs to be less than or equal to 4, so I could keep going. With this one, I'm a bit more restricted. This is telling me it's got to be greater than 1 but less than 5, so I'm looking 2, 3, 4, and that's it. And so when I look at the values that need to appear in both lists, okay, I've got 4, 3, 2, and so on there. I've got 2, 3, 4 here. So 2, 3, and 4 are my answers there. They are the only integers, the only whole numbers which work for both this quadratic inequality and this linear inequality. So 2, 3, 4 would be the answer to this question for 5 marks, right at the end, grade 9 of your GCSE. Okay, so I appreciate that this last example especially was quite complicated. You might need to rewind this and just watch it back a little bit. Please make sure you've copied down all those examples and then have a go at the questions in the booklet. Please make sure you email if you've got any questions. All right, thank you.